Okay, today the first topic, I would like to talk about voice safety. So you have seen some kind of weird situation in iPhone compiler where sometimes you forgot to do something and then you simply tell you that your code doesn't compile. Maybe the variables are not really set properly or things like that. It's something to do with voice safety. Okay, so now I'd like to show you why there's such a case and why it's worth learning. Okay, and I would like to start with Java again. Okay, since you're also familiar with Java. Also, all the Java source code and iPhone source code are already online, available. Now, let's look at the Java code over here. I got 3 different examples for you. Now, first example. Let's say we have a 2-dimensional point. We got double x, double y, and a constructor. Okay, very easy. We got another class over here called point collector, where we simply say array list of points and points. And then we have some default constructor here, and then add points, and then simply extend the point to the end of the list. And then we also can get the point as index I. Let's assume whenever the user calls this method here, they always give the valid index, starting from 0 until the count minus 1. Okay, that's what you have. And of course, you also got the import statement for array list. Now, question number 1. Does this Java code compile? Yeah. Any obvious mistake you can see in terms of types? No? Okay, very good. First of all, this code here compiles. But can you see anything that might go wrong at the runtime? Ash, how about hold it? Maybe you just get the right answer. I want to hear how people think. Anybody? Just see. So now, here's the thing. If it compiles, does it really mean it's going to be okay at the runtime? Right? Go ahead. Oh, I see what you mean. What you're saying is, over here, you're saying when we say add point, we can just add null over here, right? Okay, let's not talk about Java. Let's say null rather than void, just switching the context. Okay, let's assume that's not possible. Let's assume the user is really well behaved. Whenever they say add points, they're always going to pass the new points, really as some non-null objects. Whenever they say get point at, always the valid index. Let's assume that. Okay, it's not possible to have any invalid inputs in this respect. The points what? Okay, okay. So, anyone else who want to speak up? Just about this. Okay, so over here, the Java code compiles. However, it doesn't really mean you may not have any kind of exception at the runtime. How? Exactly what was pointed out. Okay, let's see some tests over here. Over here, let's say we got test 1 over here, JUnit test. Now, let's say we got some point collector PC. And then we have PC.addPoints, there's a new points over here. And then we have point P, and then simply return whatever we just added. Okay, we just added new points 3, 4. Now we just return it back. And well, we just assert P.x should be 3 and P.y should be 4. Now, can anybody see anything might go wrong in this test over here? Are we gonna say, are we gonna get a green bar, red bar, or something else in this test over here? If there's anything that goes wrong, tell me which line it might be. Yes? I'm comparing integers to double. I think that's okay because, oh, no, that's fine. Because P.x is double, right? And 3 will be automatically cast to 3.0. That's not an issue. Okay, how about I give you a little bit hints? That's fine, that's fine. Guys, any idea? Give you a little bit hints. It's either 4 or 5. Array start, oh, now we talk about Java, 0. Right. I'm so happy that you still like iPhone. Guys, maybe after 3311, go back to reality. Array start with 0. Okay. I'm happy you like IFO. I'm very happy. Good. Yes.
We never created the instance of an arrayless point.
Okay, that's good. Okay, now, but the question was, in the test, which line will go wrong? Which line?
4 would easily go wrong if it doesn't have an instance of an arrayless point.
Exactly. So now, basically what you will have is, in line number 4 over here, when you say pc.addPoints, that means add point over here is going to say points.add, but what point was never initialized. You can see the default constructor over here, it does not initialize this. Okay? So what does this say? This says that basically when your Java compiler says it's okay for your program to go and get executed, it doesn't mean it's going to be free from null pointer exception. Okay, that's something not so good actually, because if we can have some extra assurance to say, if you tell me that my program compiles, it can be also free from such null pointer exception, that'll be great. Okay, that's the first example. Let's do a second one. I can give you a little bit preview. If you translate the same program into IFO, it wouldn't even allow you to run, because it's going to tell you that, no, in line number 3 in the point collector class, you simply does not initialize the points. So you got a possibility of a null pointer exception. You violates the void safety principle. Okay, that's a little bit preview. Okay. Second example. Now let's say this, we still got the same point class, and we added points over here, right? Let's say we fixed that already. Now, if I go to test number 2, okay? Now let's say point collector PC, and then I say point P is assigned to null. And then I say PC.addPoint P, and then P is assigned to PC.getPoint@, 0 over here. And then I have assert true, etc. Okay? Anything wrong with this? It compiles, I can tell you, it compiles. Again, being compilable in Java doesn't really mean you might be free from null pointer exception. Do we have null pointer exception in this case? If so, which line? 5, line number 5, why? No, thinking this way, what does null pointer exception mean? Null pointer exception means, if you say line number 5, we are trying to call the method called addPoints. If you got null pointer exception, that means PC must be null. PC is not null, right? And also, if you execute line number 5, it's going to call this line over here. Also, this line here is going to initialize, it's going to execute this method here, but points have been initialized already, so it's not an issue. Yes? Say that again? Right, so you can see that, yep, okay. So now you can see the issue is, first of all, you can see that Java allows you to assign point P to be null, and then you add the null to be the first position of the points. And then when you say PC.getPoint as 0, you get back the null you just added. Now P is actually null, right? And then P.x, wow, will give you null pointer exception because P is null, right? Everybody got it? Okay. Again, another example where runtime exception occurs, especially null pointer exception, even though your program compiles. And similarly, if you try to translate the same program into IFO, you can easily do that. Also include a source code for you. And this one is going to tell you that, no, it's not going to compile. It wouldn't even allow you to run. Okay. One more. This one is even more interesting. Let's say we got points, we got point collector, the same as before. Now, the test is a little bit tricky, okay? Let's say test number 3. Point collector, and then you know about scanner, right, from Java. That's for you to read some input from the keyboard, or standard input over here, scanner. And then we say enter an integer, so we prompt the user for some integer input. And then we're gonna read the input from the user and assign that to I. Okay? Can be anything. Can be -1, can be 0, can be 2, can be -10. Now, we say that if I is less than 0, in that case, PC is assigned to null. Okay? And then we say that PC.addPoints, and then adding a new point. And you can see this new point we are adding is not null. And then we say assert true, and then get the point, and then say x is 3, and then y is 4. Okay? Again, this code compiles. Can there be anything wrong at the runtime? Okay, anybody else want to answer? Want to try? So the user, let's say in line number 5, if the user enters 5, in that case, line number 6, the if condition is going to be 5 less than 0 would be false. That means we do not reassign PC to be null, so that's okay. But it's kind of unpredictable. What if the user enters -1? In this case, -1 less than 0 in line number 6 is going to be true. In that case, we do reassign PC to be null. In this case, line number 7 is going to have null pointer exception, right? Another example here, you can see sometimes you might get null pointer exception, sometimes you may not. But there's at least one possible scenario where you'll get null pointer exception, okay? Again, if you try to translate this into IFO, it will also give you a compile time error. It's simply going to tell you that, no, you cannot write this code like this because you might have runtime null pointer exception, okay? Any questions until now? I can show you the very normal scenarios where you forgot to initialize the attributes, or sometimes you forgot to initialize the attributes, local variables, or you may simply assign something directly to null under some condition. So these are things that would not be allowed by IFO compiler. Okay? Now let's go over some idea very quickly. So now basically in Java, a program that compiles does not really guarantee you're going to be free from null pointer exception. So null pointer exception are very costly. That means you try to execute your code and your system simply crashes. It's going to disappoint the customer quite a lot. Okay? Uninitialized attributes or nullable variables, etc. Okay? So now just a little bit about history. So the notion of null reference does not start with Java. Actually, it starts with some language called Algo W back in 1965. I'm not sure any one of you programming Algo W here. I did it actually myself. Yeah. Okay? And it was by somebody called Tony Hoare. For those of you who don't know who he is, he's the inventor for quicksort, by the way. Okay? I'm sure you know about quicksort. Okay? And he introduced this notion here. He simply say that it's very easy to implement null reference. It's pointing to nothing, right? However, you can feel free. I just can tell you what the conclusion is. You can feel free to refer to this video here. So he actually talked about it was actually quite a $1 billion mistake, because as soon as you got null pointer in your programming language, like in Java, you can see the scenarios like that. And of course, those programs are simple. You might be able to experience enough to try not to have those programs. When programs get complicated, you simply cannot rely on the compiler to check for you. Okay? So your system can still crash even though it compiles. Okay, so now. Okay, so now what we want to do is we want to somehow use IFO compiler actually addresses exactly this kind of issue. It does not allow the programmer to execute the program if there's a possibility of having null pointer exception. Okay, so that's something to note. Very briefly about IFO's type system. Okay, so now by default you have seen the word detachable, right, in your lab number 3. Detachable simply means the object reference might be null. It might store something that's called void. When you say non-detachable, which means under no circumstances can the variable store anything called void or null. It's always storing to some objects, always. By default, okay? So that means anything that's going to invalidate this is going to be considered as a compile time error. I'll give you an example. Okay, let's see again. If you declare ACC of type account, that means ACC is always attached. Attached means it's going to point to some objects in the memory. It cannot be null at any point. Okay, it's always attached. And now void is just, so now void will be illegal value. Remember in the previous Java program, we even assigned PC to be null. It's not even allowed in IFO. Many of you actually try in lab number 3 to say maybe the result can be assigned to void to begin with. That was simply not allowed. It's a syntax error because IFO want to prevent any null pointer exception to occur at the runtime. So that's simply not allowed. Okay, so now here's the principle in IFO. Scenario that may make a reference variable detached, which means it will store void. They will be considered as compile time error. Let's see some example to get some intuition. Okay, so you cannot assign the variable to void directly. Result is assigned to void. It's not allowed. And also, let me give you one example here. Let's say we declare ACC2 of account, and also ACC is of type account. Now, you can say ACC is assigned to ACC2. So why is that? Here's the intuition. Because over here you can see all the variables are by default non-detachable, which means under no circumstances can ACC2 on the right-hand side be void. Under no circumstances. That's why it will be saved to assign ACC2 to ACC. Okay? On the other hand, this would be not allowed. Okay, let's see this over here. If you have ACC3 is detachable account, which means there might be some scenarios where ACC3 is allowed to be void. In this case, when you assign ACC3 to ACC, it will be disallowed by the compiler, right? Because you might assign the current value of ACC3, which is void, into ACC. Okay, that's kind of the logic behind. Okay, I wouldn't go too formally about it. I just want to give you an example. So this would not compile in IFO. Okay, and always when you're trying to create a new object, you are definitely away from the void problem. So that's always allowed. Okay. Okay. And also, if you forgot to initialize the attributes or local variables, that's also not compiled. Okay. Guys, any questions about this? Okay. The void safety is actually quite a small topic. I just want to mention that, but it's kind of important. And then I will tell you at the end what you should do once you go out of IFO, right? Okay, for the IFO program, I'll leave that to you. So if you download the source code from the web, you will see that I actually translated all the 3 versions of IFO code. I'll show you very quickly, okay? If you go to the IFO code I made available to you, if you try to compile them, you will see that they do not even compile. Just give you one example. If you click on that, you will see that over here, we say that pc.addPoints over here. It tells you that this may not compile because the target of the object call might be void. The target is PC over here. And because we might assign PC to be void from the previous line, so that means PC could be void, right? That's why it doesn't compile. But in the case of the Java program, it compiles, okay? That's kind of the distinction, okay? So you can say in some way, IFO compiler gives you some annoying error messages before you can execute your code. But it's actually trading some annoyance for, free from, null pointer exception at the runtime. So it's worthwhile. Okay. Okay, I'll let you go over the example. Okay, I don't want to waste our time. You can certainly go over. I want to make some little conclusion, and then we'll go to another design pattern. So what's the lesson we want to learn? So now over here, so you should realize that whenever you want to fix any errors, it's better to fix the errors as soon as possible, which means you would rather try to fix your compile time error rather than when your program crash and try to debug and see where you got the null pointer exception. Okay? So now this is why the IFO compiler in some way can give you more assurance to say if your code compiles, it means you should not have any null pointer exception. It's guaranteed. Okay? Okay, now, and this is just an analogy. So you rather have some void safe design for an airplane. So you rather to have any problem to be sorted at the design phase rather than saying when the airplane take off and then crash, right? That's some analogy here. Okay, so now this is what I hope you will take away from using IFO this semester. So let's say you're so used to getting compile time errors when you didn't, let's say you didn't initialize the attributes or local variable, you're so used to it. Let's say later on you go back to your Java, your C++, or go back to your C#. Now, because you're so used to this notation here, later on you will just always initialize your attributes, always initialize your local variables, even though the compiler over there doesn't care. But you should care as a programmer, right? You should care about the null pointer exception. That's what I hope you will take away. Okay, and here are some more references if you're interested, but I will encourage you to watch this video by Tony Hoare, just about why it's $1 billion mistake to have null references. Okay, it's completely worthwhile. Any question about voice safety over here? Are we okay? Okay. So now when you do your project and when you do the remaining 2 labs, So whenever you got anything like a voice safety issue, hopefully you will see what's going on there. Right? If no questions, I'll go on to another design pattern. Okay? Observer. Okay? This is quite an easy pattern actually, but it's really worthwhile to see, again, to give you some initial design which may not be so ideal and let you criticize it. And then we go move on to observer pattern. Okay. What's kind of the motivating problem here? So this is just one example. Let's say we have some weather station there which monitors different measures like a temperature, pressure, or I always forget what the other one is, humidity. Let's say these are the measures we are observing from the weather station. And let's say at the same time, we also got some weather data related apps over here. So maybe one app, so let's say we got different apps on the weather data. So maybe let's say we have some application on condition to say, what's the current temperature in Celsius? And also, what's the humidity level in percentage, right? That's one possible app, okay? Or you might have some forecast application. In the case, based on the previous pressure and the current pressure, if the pressure has been reduced, maybe that means it's going to rain. You know, I'm just oversimplified what's going on here. But that can be another kind of app. So it's also going to make use of the data. And the third one, for this example, the lecture here, maybe it will summarize its statistics about the temperature. What's the minimum, what's the maximum, after what's the average temperature so far, right? You also see that kind of statistics. So the problem is, we do have the weather station here. It's an only single weather station, but its data, part of it might be used for one application. Another part of it might be used for another application, and another part of it used for another application, right? For condition over here, we only make use of temperature and humidity, okay? For forecast application, we only make use of pressure. And for statistics, we only make use of temperature, you know, things like that. Is the problem clear to everybody? Simple problem, okay, weather station. So now let's see how we can solve this problem over here. Okay, first design. Let's just put a design architecture here rather before I show you the code. Okay, let me switch to iPad over here and then see what's going on. Okay. Okay, this one is fine. Okay, this is the architecture for the first design. Let's try to understand what's going on here just from the design. Okay, again, you can see there's no inheritance over here, only the green arrows, which means we got client-supplier, right? So we got 3 client-supplier relationship over here, and the name is simply called weather data. So you can think of in forecast, in current conditions, in statistics, we declare attributes of type weather data. Okay, that's what we have. Under weather data, what do we have? I just go over the attribute very quickly. So you got temperature, you got humidity, you got pressure. And also, I'm going to show you the exact code in just a moment. You also have some Boolean query over here called correct limits. So the temperature, the pressure, and also humidity, they should be within some legal limits, right? The temperature, for example, cannot go above 200 or 100. Well, I'm exaggerating it. There's got to be some legal lower bounds and upper bounds for all the measures. And then this is the most interesting bit for the first design, which will also be used for the second design. We have something called a class invariant over here. Anyone can tell me from what you have learned, what does class invariant mean? Try. Class invariant. Yes. Is it's a property for all the objects. Yeah, for all the instances of the same class. So now we talk about weather data, right? So we want to define under what circumstances should we say the weather data is valid. So it's a validity constraint on the weather data. If you go above the constraints, then or go below the constraint, that means the weather data is not valid anymore. Okay, that's class invariance. Okay, so I would say this is really something you want to pay the most attention to for the first design. So this is a really good thing, invariance over here. Okay, now let's look at the client side. Okay, you can see this is, again, for those of you who are still confused with who the client should be, who the supplier should be. So when you have the arrow here, it's always the case that clients points to supplier. Okay, this is supplier. And these are the clients over here. So we got 3 clients here. We got forecast, we got current conditions, we got statistics, right? So now over here, you can see that all of them got something called weather data of the same type, weather data. Over here, that means they can get access to it, okay? And also they got something called display, and also display. So that means they can display for their application-specific information. For example, for statistics, it's going to display only some information about the temperature, what's the average, what's the minimum, and what's the maximum, right? And also for current condition over here, it's going to display the levels for temperature and also humidity, etc. Okay? That's the first design, okay? And I can tell you that the first design works pretty well, okay? So any question about the first design? Any questions? Okay, if no question, let me show you some IFO code very quickly, and then let's criticize about it, okay? Okay, let me just tell you one thing. This can be some hints for the potential disadvantage for this first design. Basically, this is to say, the only way, let's say for the forecast app, the only way for me to get the latest data for pressure is by calling weather data dot pressure, right? Because weather data is of type weather data. I gotta say weather data dot pressure. That's the only way I can do it, okay? So now, for example, I will put it here. So for forecast over here, I can say weather data. Thank you. So switch the wrong side. Yeah, thank you. Yeah, so I can say weather data dot, and then I can say, for example, in this case, current temperature, I can say temperature. You will see the code in just a moment, but I just want to point it out, okay? Whenever you want to display the latest measure for the temperature, you have to query about what the weather data is, the latest one, okay? Now remember, weather data comes from the weather station, which might be geographically distributed somewhere, very distant, okay? That's what I want to say for now. Okay, let's see some IFO code very quickly, and then I will ask you to criticize the design, okay? Let's say we got the class called weather data here, and then we have temperature, we got humidity, we got pressure. Nothing special, very straightforward. And then we also got something called correct limits. So we're gonna say for all the temperature, humidity, and pressure, so for example, let's say result, if it is valid, that implies the temperature must be between minus 36 and 60, for example, okay? And then also for pressure and also for humidity, okay? And now here is the thing. When you are trying to make a new weather data instance, you have to make sure that T, P, and H you pass is actually correct limits. Otherwise, you would have initialized some invalid data, which will violate the invariance, okay? And then you do it, okay? That's a post condition here. And then the invariance, correct limits. You want to make sure all the time throughout the lifetime for any weather data objects, the limits are always correct for all the 3 data there. Okay, any question about this contract view over here, right, for the weather data? Yes. Good question. Very good question. The question was, since the invariance is already over here, why do I still repeat that in the require? Okay. Now let me just go back to our very first week. Okay. Remember we said the obligation for the clients is only the precondition, right? Okay. And what's the benefits for the clients? It's postcondition and also invariance. Now, in this case, if let's say we got rid of the require over here, let's say simply it's not there. If we pass a temperature, for example, that's minus 50, that's below the lowest bound, right? If we pass 50 over here, that means when we check the post condition, remember invariant is also the post condition for every feature. In that case, we're going to violate the post condition. That means the clients, they pass something there, but they actually got some invalid object back. So they must be very upset. So what we should, the correct action should be, we should stop them by passing this data here. So that's why it should be a precondition, okay? over here. And another thing to note, usually one strategy for deriving your precondition should also be looking at what's the corresponding invariant. So invariant is really the key to think about what it means for some object to be valid. Okay. Any other questions about weather data? Okay. Now let's look at the current condition. Remember again the diagram here. So what we just talked about was the weather data. So let's talk about the different clients over here. Okay. Let's talk about the current conditions first. So the current condition here, you can see that we only worry about the temperature and humidity. We don't worry about pressure. Not necessarily every application is going to make use of all the data, only part of it. And then we have the weather data here of type weather data. This is why you got this green arrow over here again. Okay? That's how you translate from architecture into programming. Okay? And then we can simply say when you try to make a new current conditions app, all you got to do is to pass some weather data objects, and then just pass and just make sure weather data has been set to be whatever the input is. Okay, so this means later on, if you want to update the weather data, you know where to go. Okay. Also updates. So now for the app to update itself for the latest measure, this is what it does. You simply say the temperature is assigned to weather data.temperature. And also humidity is assigned to weather data.humidity, right? Now one thing to note, you can see this weather data here comes from some weather station, which may be connected to the app using some network connection, or maybe some Wi-Fi, or maybe a cellular network. So now whenever you try to say weather data.temperature, it can be potentially costly, right? Because that means every time you want to query about what's the latest value for temperature and for humidity, you have to connect to the weather station on the remote end. So I'm not sure in your previous Java course you learned about something called remote method call. Okay, that simply means you can make some remote request. Okay, that's something I want to say. And then for display over here, what does it really mean when you want to display? You want to make sure for the application there, with every time you have the app displaying the latest statistics. So now, take a guess. What would be the first step for display? I want to make sure whatever I display will be the latest measure. So what would be the first step for display? How do I update the temperature and also humidity? Call updates. Exactly. Yep, that's the first step. Okay, that's always the first step. Okay. Now you can see that if I try to update the display every 2 seconds in my app, in that case, every 2 seconds I got to call this procedure over here. So now even if the remote end, if the weather station has not changed its weather data, I'm actually wasting some resources over here, right? Even though the data has not been updated. That's something to note. Okay. And then the rest is simply just easy. You can say, oh, what's the current condition, temperature, and humidity, etc. You can run the IFO code to see what's going on. Okay, the most important thing for you to know in this code here is we try to connect this particular current conditions here into some remote weather data. Okay? And then every time, if you want to update the display locally, you have to make some remote connection to the weather's data. Okay? That's why this can be potentially costly, potentially. Let's see what's going to be the code for the forecast application. It's going to be something very similar, very similar. Again, for forecast, we only depend on current pressure and last pressure, only the pressure measure. We don't care about temperature, we don't care about humidity, only the pressure. And then we also got a link to the weather data as before. Okay? Again, that's why you see this green arrow here. Okay? Now let's go back here. And then, so we say that after you create a new forecast instance, you got weather data is weather data. Updates, you simply update the current pressure and also to cache the latest pressure, right? You got old pressure and the current pressure. If the current pressure has been reduced, that means you might have some rainy weather or cooler weather. Okay? That's kind of the kind of oversimplified, for the simplification for this example here. And for display, you can see that again, every time before you display on your app, you want to make sure you you make your computation out of the latest measures. So that's why you gotta do an update. Again, for this update here, you gotta really query about what's the remote end, the pressure, okay? And then you can just do the rest. Any question about this one here? Okay. I'm kind of going a little bit fast on this first design, but hopefully you see the idea, right? For the architecture. We only have one end link. Okay, good. Next one. What about statistics? Again, very similar. Okay. Again, we got weather data here, attributes. So that's the third green arrow over here. And then we have the temperature only. We only care about temperature. But we have to somehow keep track of what's the minimum, what's the maximum, and what's the average. Okay, you can see the computation is very easy. And then whenever we create a new statistics app, we have to link the weather data. Okay? And then we say updates, we only update the temperature. That's the only thing we update. And what about display? Update first before you display the rest. Okay, that's about the statistics. Okay. Let's now see the weather station. Okay. What about the weather station part? Let's see what can happen in the weather station. Of course, again, this is simplified version. In weather station here, somehow we have the different apps. We got current conditions, we got forecast, we got statistics. Also, we have some weather data. Okay. We can say we initialize by making some initial data over here with temperature, humidity, and pressure. Okay, just some initial data. Okay, and then you can see that we try to initialize the three applications over here. And there you can see we pass the same WD reference, which means all the three applications are linked to the same WD objects, right? That's what this line does. And then you can see WD.set measurement over here. That means we are changing, the weather station is changing its measurement. Okay, you can see the temperature has been increased from 9 to 15, for example. And the humidity has been decreased from 75 into 60, something like that. Okay, so now the measurement is changed. Now in this case, if we say this, current condition that display, and also forecast that display, and also statistics that display. So what does that do? Remember, for each one of them, I just show you one, just review very quickly. For each one of them, you have to call the update first, right? To make sure we really get the latest one. Now, let's go back here. Question for you. As I said before, when you say these three displayed, you are trying to make some remote communication, right? You want to remotely request what the latest data from the weather station. In this case, do you think the computing resources has been used properly? Or have we wasted any resources in this case? In this case, I would say we haven't, because you can see if we didn't say the updates, in this we'll still be displaying the old data, right? Because you can see that if we didn't update before we display, in that case we'll still be getting 9, 75, and 25. We wouldn't get the updated version, right? Now, let's say this one. I want you to compare really these two. These are really the keys, okay? Now you can see that in line number 11 and line number 13, we're making exactly the same sequence of calls. In line number 11, it's kind of worthwhile doing the updates because the temperature, the data has been changed from 9, 75, 25 into 15, 60, and 30.4. Now, is line 13 really necessary? Are we wasting the resources, really? We are, right? Because you can see between 11 and 13, there is no set measurement occurring. In that case, even though we are still making the remote request, but the data are really the same. So we are not really getting anything new, okay? Okay, that's something to note. And this is really the main drawback for the first design. On the other hand, let's say we try to change the measurement again. In this case, if we do display again, that'll be worthwhile spending the resources. Okay? So now, any questions? Are we okay? Okay, so the key really is to know that in the first design, in situation like this, where there's no really any updates no really actual changes on the weather data. When you say updates, you're really wasting your resources communicating to the server, okay, or to the weather station, okay? And the fundamental reason for that is somehow for the 3 applications there, they simply have no idea when the changes really occur, because the changes might happen over here, the changes might happen over here, but the application have no idea. So it would be better to have a design where you try to notify the changes to the applications rather than them communicating with the server. So we are trying to change the direction of communication. Okay, so kind of the insight for observer. Okay, now, is first design really a good design? To some extent, it's good, to some extent. Okay, let's just go over that. Actually, I pretty much said everything already. Okay, let's just go over the point very quickly. So now you can see that each application over there, they cannot simply know when the data have been changed and when to do the updates. So they simply just guess. So every time they do the display, they just updates. But that might waste the resources too often, okay, to make the remote request. Okay, and then remote cost, so you might be wasting the network bandwidth, etc. Okay, so now, this is the only drawback for the first design. It might be working well, but it might be wasting your resources. So now, how can we avoid such overhead? Okay, here's the idea about observer pattern. Okay, let's just see the pattern. Let's see the summary points, and then we'll get to the architecture. So now, first of all, we say that each application, the current conditions, statistics, and forecast, they subscribe to the weather data. Okay, that's how we say they're linked to the weather data. And then we say that, so somehow the weather station itself, which we call the subjects, they are aware of the list of applications that are subscribed to itself. Somehow this is really important. So that means whenever the weather station has any updates on the measurements, in this case, it's simply going to notify all the subscribed applications. Okay, we're going to see this in the architecture. Okay, so now this is really important. In the observer pattern, the updates only occurred when necessary, which means when the subject, the weather station has updates, it will cause the subscribed application to really do the updates. Otherwise, they will always use the cache data on the local copies. Okay, guys, any questions before I move on to the architecture? Are we okay? Let's see the architecture. Okay. So now this is just in general. Let me just talk about the general architecture very quickly, and now I'll introduce some terminology. Okay. So this is just the observer pattern in general. So I want you to pay attention to some terminology over here. You can see something called subjects and something called observers. Okay. Sometimes people like to call this slightly differently. I'll write it down. Sometimes people want to call publisher versus also subscriber. Okay, so so you can call it observers or subscribers, subjects or publishers. Okay, you can use them interchangeably. Okay, and also here, this is the critical bits. Oh, let me just go over individually, and then I'll tell you the critical client-supply relationship. Okay, you can see that we got something called subjects over here. And the subject simply got an attribute over here called observers. So this will be the list of observer. For example, in this case, the weather station maintains a list of applications. Okay? And then we got something called notified, which means whenever there's any change on the subject or publisher side, we notified all the list of observers. Because given that they already subscribe to us, given that. Okay? And then this is some important contract over here. I'm going to write it down. Okay? So here it simply says that notify is a command. And what's the post condition? And the post condition will be interesting to see. It says that, I'm going to show you how to do this in iPhone in just a moment. It says that for every observer O in the list of observers, it is the case that the observer has been up to date with the subjects, okay, after the notified. Up to date with subjects. And of course, you might be wondering, how do we define this feature here? This feature depends on the particular application you have. I'll show you that. It's actually quite easy. For example, for the case of the current conditions, what does it really mean when the current conditions app is up to date with the subject? That means the temperature and also the humidity are up to date, right? And for forecast, that means the pressure is up to date, etc. Okay? That's about the subjects. And then you may have as many subject descendant classes as you like. Okay? Any question on the subject side? Okay? In the next diagram, I'm going to show you exactly how this can be applied to the weather station example, but let's talk about in general. Okay, now observer. This is the observer class. And now what do we have? First of all, we got something called updates. So which means whenever the subjects want to notify all the observers about the changes, what they can do is simply just say, go over all the observers in the list and then call the updates feature on them. Okay, so update is actually a feature of the observer. When you call the updates, again, polymorphism and dynamic binding, right? Because updates is defined in the static type of observer over here on the top. And over here, down in the hierarchy here, we got different observer subclasses. Now, depending on which one you're talking about as the dynamic type, the corresponding version of updates is going to be called. That's dynamic binding. Okay? And then also we got up to date with subjects. That's also something you have to define for the observer. Okay? It's a little bit abstract, but I just want to go over with you the architecture. One more thing over here. Client supplier. So this is something called attach and detach. So it's actually something about a subscription idea. So it's like you're trying to subscribe to some newspaper or magazine. So when you subscribe to the news feed, that's okay, don't worry. When you try to subscribe to the news feed, whenever they got a new update, they will send to all the subscribers. As soon as you unsubscribe from the news feed, and you will no longer receive any updates. That's exactly this analogy over here. Okay, so now I will talk about attach and detach. Attach means we want to add an observer O into the list of observers for this particular subject. And similarly, when we say detach, that means to remove the observer from the list so that any further updates will not be notified to that particular observer. Guys, any questions conceptually about this? Before we see a concrete application for observer pattern in our example. Okay? Okay, let's see how we can do that for our weather station example. So that's the concrete pattern over here. Okay? Again, let's go over one by one. Okay? And then I'll show you Eiffel code. First of all, you can see that over here we got subjects, we got observer, the same as before, okay? And then we got observer list, we also got notified on the subject side. On the observer side, we got updates, we also got up to date with subjects. Okay, so these are just deferred. We don't know how they are defined just yet. Now, the only descendant class of the subject in this case is called the weather data. Okay, and the weather data here, we got temperature, we got humidity, we got pressure. And also we got the correct limits, right? And also we got the invariance over there. Okay, same as the first design. We just use the best part of the first design, the good part. Now the observer side over here, you can see we got forecast, we got current conditions, we got statistics, right? They are all effective, which means they don't have any features unimplemented. And you can see this is inheritance. Okay, so they are all descendant classes. Now, one thing to say. For example, let me give you some example over here. So now, on the subject side, when I say observer, let me just give you one example here. Let's say observer O of type, let's say forecast. Observer 2, and then let's say we have statistics. Let's say we got these two objects, assuming that they have been created already, okay? Now, how do we add these two? How do we subscribe these two observers to the subjects? What we can do is, we can say, for example, let's say WD, weather data. Okay, over here, what we can do is, we can say WD dot attach. And then we can say O1 and also WD dot attach. And also O2 attach, okay? Attach these two. So now that means the list of observer over here contains both O1 and O2. Okay? Now what does it really mean when we say the following? When we say WD, which is a subject over here, when I say WD that notify over here, what it will do is going to go over the list of observers. You can see that over here, the type over here, the static type is observer. Because of polymorphism at the runtime, the observer can be either forecast, can be current conditions, or can be statistics, right? Now, when I say WD.notify, it's something like this. It's going to go over a loop. So you're going to say, I'll just write two iterations out. You're going to say observers at position 1, observers at position 2. And then for both of them, we're going to call updates. And updates over here. And now you can notice that it's the same feature we are calling. What's going to be the difference of the effects of these two lines? The first line, observers 1 dot updates. Line number 2, observers at position 2 dot updates. Yes, Andre, I remember your name. Yes. Oh, by the way, start with 1, right? The array. Yeah, good.
So, for observers who want that update, we'll call the forecast update?
Yes. Yeah, because dynamic type is forecast. What about observers 2? Exactly. Very good. Thank you. So what Andre said was exactly correct. So basically, even though we're calling the same feature here, but because of dynamic binding, depending on what's the dynamic type for observers 1, in this case, it's forecast. It's going to call that version. In this case, it's statistics for position 2. Okay? Guys, any questions until now? For now. You can study the complete architecture a little bit more. It's actually rather simple, but I just try to make it as complete as possible. Okay? Of course, so far we have talked about quite a number of design patterns. For your projects, it will be completely up to you which one you want to apply. It might be observer, it might be, right? So you gotta decide. And then I'll read your report when you submit it, okay? By the way, any one of you still having trouble with finding partners for your team? Everyone's okay, right? If you still got trouble here, maybe you can approach me, maybe after class, I'll try to find you one, okay? I'll try to, good. Okay, now, very good. Now, let's now go over very quickly the code for the architecture. Oh, some vocabulary I would like to mention very quickly. So sometimes people talk about different words that really mean the same thing. So first of all, when you see observers, that's more like I believe in Java, they usually like to talk about observer. But some other languages, they like to talk about subscribers. And also subject is also called publisher. Okay? There's also, when we say observer pattern, sometimes people say publish subscribe pattern. That's also very well known. Okay, so now when you say attach in this case, which means you want to attach a particular observer to the subjects, you can also say register, you can also say subscribe. Okay, and also you also got unsubscribe and also unregister or detach, right? Also, when you want to notify the observers about the updates, you can say notify or publish. Okay. Finally, when you say a particular observer, when they want to update their measures, update the things they're observing, you can either say handle or you can say updates. Okay. So these are just common terms. You can. It's good to know them. Okay. Now let's see. So that's the diagram I just went over. So now let's have a look at the code very quickly. First of all, we have the observer class. Okay. By the way, so all the code is available on the web, so you can also play with them. Okay. Observer over here, and then we say that we have, first of all, up to date with the subjects. In this case, Now we are only at the observer level over here, only the observer. So we don't know yet what does it really mean for the observer to be up to date. We'll define that in the concrete, in the effective descendant classes. We'll do that. Okay? And also we got something called updates. So what does it really mean when you want to keep up to date? You can see the only thing we say is called ensure. So we can say up to date with subjects and up to date with subjects over here. Remember we talked about some subcontracting 2 weeks ago. So what does that mean when we have ensure over here? That means it's going to be conjoined with any post condition you might put in the subclasses. So don't forget, it's conjoined. So that's going to be accumulated. Okay? So that's why it makes sense to define this at the top level. Okay, okay, good. Now, so for each descendant class, you should really define what does it really mean for the weather data to be up to date for your particular application and how you update them. Okay, let's see how exactly we do it. For example, for current conditions over here, let's see what we do. You will say that inherit from observer, and then you say when we create a new current conditions, we still pass a weather data, right? Weather data here. See what we do here. That's going to be the difference. We say that first of all, weather data is assigned to a weather data. So this corresponds to, let me just go to iPad. So this corresponds to this green arrow over here, okay? So that means the forecast for each of the applications still refer to the weather data. They still refer to it, okay? Because sometimes we may still have to make the remote request when necessary, okay? But now this is a new line. Let's try to understand what this really is saying. We're saying that for the weather data, which is the subject or the publisher, we want to attach the current observer to it. So we are trying to build the links bidirectionally, right? Let me just illustrate that very quickly, and then we can do similar reasoning. Okay, let me just do that over here very quickly. For example, let's say this is our weather data object over here, and then over there we have one attribute called observer. And then it's simply a list, okay? Initially just empty, okay? And then let's say we have over here the app, let's say forecast. And then for the forecast over here, we got one attribute over here called weather data, WD, okay? So now let's see how the links are really set, okay? Now let me show you here. First of all, let's see the first line. Weather data is assigned to a weather data, okay? So now this is a weather data, okay? So now when we say, let me just use the in color here. When I say weather data is assigned to a weather data, so that means this is going to point to here. Okay, that one's easy, okay? Which means later if I want to get the latest, maybe pressure for the forecast, I can always use this link to get it, okay? Now, on the other hand, let's see the second line. When we have weather data that attach current, okay? So when we have over here, weather data dot attach, weather data dot attach, and then current. Current is simply just this forecast, I'll say FD, and then we just attach FD, okay? So what does that mean? That means over here, we're going to add a new observer over here, and this is going to point to here. So we got bidirectional link over here. So that means this, FD dot weather data is equal to a weather data. Okay, we got aliasing here, right? So they are pointing to the same objects. Similarly, a weather data dot observers at position 1. This is pointing to exactly FD, okay? So now this is something you can see. Okay, that's what happened at runtime. Of course, you might have more than one observers in the array or in the list. Any question about setting these links over here? You always set the links bidirectionally, okay? In the first design, we only set a green link, only that one. But now in the observer pattern, red link also has to be set. So now, what's really going to be important is, whenever any updates, any update that really occur on the weather data site, what we will do is we're going to use this particular link over here to tell every observer over here to updates. Okay, that's going to be initiated from the subject side. Okay, not really from the observer side anymore. Okay, that's a crucial insight into the observer pattern. Okay, now let's see what's going to. Okay, so post condition is the weather data the observers that has current. Okay, that should be quite obvious, right? So now it's really one of the observers. And also now, under the context of current conditions, what does it really mean when it is up to date with the subjects? That means because we know that for the current conditions, it only cares about humidity and temperature. So that means we only say the temperature must be up to date, and also humidity must be up to date as well. That's for writing contracts, okay? And now, when we say, we can also say updates, okay? Now the updates will only be called, will only be initiated by the subjects, okay? Which means over here, whenever the weather data has changed, we're gonna say notified. And notify is gonna run a loop and say observer 1, the updates. Observer 2, updates, etc. Okay? And also we got display. So now for display here, we don't have to do updates every time anymore. Remember in the first design, the very first step for every display is to update. Now we don't have to do that anymore because we are pretty sure whenever there's any necessary updates, the subjects that we are observing already notify us and do the updates already. Okay, that's really crucial. Think about this picture at the runtime. Okay, similarly for forecast, I'm gonna just go over very quickly. You also got this attached over here by setting the bidirectional link, and then you're gonna do over here. What does it really mean to be up to date for the forecast? That means your pressure is up to date, right? Only the pressure. Okay, and then also you do the updates on demand and display. And one more, statistics, similar. Okay, you also gotta attach. And then what does it really mean when the statistics is up to date? Temperature. In this case, you should make sure the temperature is up to date. Okay, I'm going a little bit fast, but any questions about what we have gone through so far? So now what we have done was we just gone through the observer side. If I show you the diagram over here, we have seen all these classes already. All these classes. We haven't seen the weather station part. That's the subject side. We're going to see that. That one also there is not too bad. Okay, now let's see that subjects. For the subject here, in general, we're going to support some features that can be reused. So we got observers here, and then it's going to be a list of observer. And then we also got make. So over here, we simply just create an empty list, for example, linked list. And then anybody want to try, I want to just ask you quickly, how do I write this particular contract post condition here to say, initially, after the subject is created, there should be no observers to begin with? Ash? Yeah, it's empty, yeah, see what you mean, yeah. Good. Okay, now let's say we want to attach. I want to attach a particular observer into it. Now notice that it's polymorphism. Any descendant class of observer can be added. Okay? Any of the descendant classes over here. Okay? Now, I forgot your name. Mahu. Okay, Mahu, please. How do I specify the precondition here, not yet attached? Which means the observer I'm adding should not be subscribed yet. Okay, just look through the collection and make sure it's not there, right? Yes, they do have it. Exactly. Not observer that has. Very good. Now, what about the post condition? MJ, post condition. The precondition was that the observer was not there. What about the post condition? Huh? Still not there? Really? Yeah, it's there. Yeah. The other way around, yeah, exactly. Yeah. Very good. Okay, detach, okay? It's very easy, just the opposite. Before that, it should be there already. After that, it's detached. Okay, very easy. Okay, now notify is more interesting. Now notify. Now for notify, that means we're going to notify for every observer in the observers list. In this case, can anybody try? We have seen, I can give you a little bit hints. What we have seen was back in the general architecture over here, that's exactly this for all I just talked about. Okay? I want to say for every observer, it's up to date. Now, can anybody try to tell me how to write this in iPhone quickly? Yes. Across observers as, let's say, cursor, for example. I'll give you a choice, or some. All, very good. And then, what should you write over there? And then, okay, cursor.item, and then whatever the feature name is, right? Good. Exactly. Okay, that pretty much corresponds to the for all quantification over there. Okay, guys, any question about this? That's about the subjects. Okay, let's now do weather station very quickly. So weather data over here. So now inherit the subjects. And then, so now one thing I want to just mention, there's something you can also use for your project if necessary. So here we want to say, in the subject class, we do have a make feature already, as you can see. We have a make feature. But somehow if I want to refer to it, now the problem is, we also want to say create make for this particular class. We want to avoid name clashes. We have a make in the current class. We also have a make in the superclass. So the way to do this to resolve the name clashes is to say, rename the make in the superclass to be make subjects. Okay, that's just some, I would say this one, you just look up the slide and see how to do it. So this one is not really, does not require too much intelligence. It's not very interesting. And then for the weather data here, we got temperature, humidity, pressure, correct limits, etc. Okay, and here I can just call make subjects, right? So make subject refer to the make in the superclass, which simply just create empty observer, as we said before. Okay? Okay, and then what we can do later is to set whatever the measurement is, okay, to be T, P, and H. Okay, similar as before. Okay, nothing special. Okay, let me just give, how about 2 minutes and then I'll be done. 2 minutes. Okay, what about weather station? For weather station here, we simply declare the variable as before, current condition, forecast, statistics, and weather data. Now I want you to compare what's going to be the change over here. So we create some initial data here, and then we have also create the different application here. Remember, for each make, it's going to be bi-directional setup rather than just unidirectional, something to note. And then when we change things over here from the weather station side, we're going to say wd.notify. And this notify over here is going to go across every observer and then call the updates on them. Okay? And then now when we say display, 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 now the display here is going to be some local computation because display does not require updates anymore. So we can simply just use the local values that has been stored. Okay? That's something you should really try to compare. Okay, and then just notify whenever you got new changes from the subject side. Okay, let me stop the recording here.